The Department of Defense is constantly working to improve the equipment it supplies to troops. No doubt the evolution of gear has come a long way, even in the past decade or so. But someone has to develop and test the latest and greatest before it makes it into the hands of troops. Thanks to Program Executive Office Soldier and the Joint Non-Lethal Weapons Directorate, two groups responsible for these developments, we were able to get an up-close look at some of the newest and future military weapons. Proving ground in Maryland for a day of weapons demonstrations, we were there faster than rounds flying downrange. Not only did I get to see the newest weapons the Army has developed, I got to try them out. Some, like this one, the M107 sniper rifle, are already in the hands of soldiers. Other weapons, like the XM320 grenade launcher,
5-meter burst radius, you would have got them both,
are in the final stages of testing and development and won't be fielded for another year or so. All are designed with the needs, comfort, and versatility soldiers demand. This is the Common Remotely Operated Weapons Station, or CROWS. Basically, it's like any video game. You have a joystick, you have a monitor. It's as simple as squeezing the joystick, moving it around to where you want, and when you're ready to go, you pull the trigger. This is the M110 semi-automatic sniper system. It was developed because snipers are saying they have to engage more targets more quickly than before.
Nice shot, cinematic. It feels just like an M16. There's really no kick to it at all.
This is a 12-gauge modular accessory shotgun. It can be used as a standalone weapon or attached like this to the bottom of an M4, eliminating the need to carry around two separate weapons. This M249 squad automatic weapon, or SAW, is a little bit different than its predecessor. You've got a collapsible buttstock, so you can adjust it to your size. And also, the benefit of this is it helps for room clearing, getting in and out of tight situations. That's why also, if you notice up at the barrel, that's also shorter. A 2.5-hour drive down Interstate 95 from Aberdeen is Marine Corps Base Quantico, Virginia. There, the Pentagon Channel's Staff Sergeant Raina Barnett met up with the DoD's Joint Non-Lethal Weapons Directorate. They were showing off one of their latest products, the Active Denial System.
It's basically a radio transmitter that produces a beam of energy that goes downrange at 95 gigahertz, which is getting a little bit technical, but that is a frequency that when it hits the human skin is only absorbed 1/64th of an inch. Now, when it's absorbed into the skin, what it does is it creates a heating effect. So as that heat builds on the human, it doesn't create any damage, but what it does is it causes people to move out of the way.
Feels like you are literally sticking your body into a 425-degree oven.
Operator target control. Target is the center target in the box. Center target in the box. You are clear to engage.
We've just been engaged with the Active Denial System. As you can see from 800 meters away, it can actually target one person within a crowd without really affecting the other people.
Officials say the ADS could be fielded by early 2008.
ATK has led the development of the Individual Airburst Weapon System designed specifically for the Counter-Defilade Target Engagement System. The initial 20mm weapon system transitioned to a 25mm system. The resulting XM25 Individual Airburst Weapon System and XM104 ruggedized, fully integrated, day-night target acquisition and fire control system will meet the requirements for the Counter-Defilade Target Engagement System. The ammunition family currently being developed by ATK consists of a 25mm high-explosive airburst HEAB round and a target practice TP round. A complete family of ammunition is planned to be developed, including armor-piercing, anti-personnel, and both airburst and point-impact non-lethal rounds. An inert signature burst training round and virtual reality force-on-force training simulation are also planned to lower life cycle costs. The HEAB round is a 25mm cartridge with fore and aft explosive warheads and a mid-body airburst fuse. Over 3,000 rounds of HEAB ammunition have been produced for testing and evaluation. The round has exceeded dispersion and airburst accuracy requirements, ensuring the probability of incapacitation at 500 meters for point targets and 800 meters for area targets. An operational firing scenario would involve the following. By viewing through the fire controls display, the combat user puts the red dot aim point on the target, pushes the laze button, realigns the adjusted aim point on the target, and fires. The range is automatically communicated upon firing to the chambered 25mm round and stored in the fuse logic. Upon muzzle exit, the intelligent fuse, using a turns counting approach, determines the distance traveled and bursts precisely over the engaged target at the programmed range. The individual airburst weapon system is designed for the combat soldier and future force warrior to revolutionize the infantry battlefield with lightweight precision and devastating lethality effects from the 25mm high-explosive airbursting ammunition. And with ATK's individual airburst weapon system precision, it leaves the enemy no place to hide.
Those really smart people out of Sandia Labs have come up with a bullet that doesn't miss. Sandia scientists and engineers have wide expertise in miniature technology, nanotechnology. And the bullet is actually a tiny guided missile. News 13's Scott Daniels has more from the Newsplex.
Dick, this patented design would give superpowers to average shooters. It could change the way American soldiers are trained on the front lines.
This laboratory is about building very, very tiny machines.
James Jones and his team of engineers at Sandia Labs has turned average-size ideas and made them enormous by shrinking them down.
The actual one is this dot right there in the middle.
Their newest project, to take a self-guided missile and put it into a .50 caliber rifle. It shoots like a dart. Instead of shooting straight with a spiral motion, it twists and turns to find a laser-pointed target at the end, making up to 30 corrections per second while in the air.
From the sensor, it commands little fins in the back so that the bullet pitches and yaws and turns itself and guides itself towards the laser dot.
In theory, put these into soldiers' machine guns, and they'll hit their mark faster with precise accuracy, so soldiers can spend less time in a firefight.
We've tested gunpowders to see if we could get muzzle velocities of military interest. We've tested various electronic components to see if they would survive launch.
The team wants to continue testing to see if the bullet they've spent 3 years developing could help our military. They need a sponsor to take the prototype and manufacture it on a commercial scale. Jones says that's the target they've been aiming for. Research and development grants have taken the project this far. Jones says it's about halfway through being fully developed for commercial use. Back to you.
Okay, Scott, the Discovery Channel and the BBC are planning stories about this Sandia bullet.
The Navy's Office of Naval Research conducted a record-setting firing of an electromagnetic railgun at Naval Surface Warfare Center, Dahlgren, Virginia. The audience included the Chief of Naval Operations, Admiral Gary Roughead.
We should never lose sight of always looking ahead, looking to make our capability better, more effective, and as warriors, more lethal.
The railgun projectile, moved forward by electromagnetic energy instead of explosive propellants, raced toward its target at a record-setting muzzle energy of 10.64 megajoules. In the future, the railgun will be able to fire a projectile more than 200 nautical miles.
The projectile will launch and go into outer space and then come back and put steel on target at Mach 5.
Our ships are never going to be able to get as close to the shore as they can now to provide fire support for our Marines, Special Forces, other services as they go ashore. And this gun will do that for us.
The program's goal is to demonstrate a full capability integrated railgun prototype by 2016 to 2018 timeframe.
Something big is going on in war today, and maybe even the history of humanity itself. The U.S. military went into Iraq with a handful of drones in the air. We now have 5,300. We went in with 0 unmanned ground systems. We now have 12,000. And the tech term killer application takes on new meaning in this space. And we need to remember that we're talking about the Model T Fords, the Wright Flyers, compared to what's coming soon. That's where we're at right now. One of the people that I recently met with was an Air Force 3-star general, and he said basically where we're headed very soon is tens of thousands of robots operating in our conflicts. And these numbers matter because we're not just talking about tens of thousands of today's robots, but tens and thousands of these prototypes and tomorrow's robots. Because, of course, one of the things that's operating in technology is Moore's Law, that you can pack in more and more computing power into those robots. And so flash forward around 25 years, if Moore's Law holds true, those robots will be close to 1 billion times more powerful in their computing than today. And so what that means is the kind of things that we used to only talk about at science fiction conventions like Comic-Con have to be talked about in the halls of power, in places like the Pentagon. A robot's revolution is upon us.
It's not Pixar's WALL-E, and it's not Short Circuit's Johnny 5. It's the U.S. Army's MarkBot 4. The MarkBot, or Multifunction Agile Remote-Controlled Robot, is one of the Army's tools for detecting IEDs.
Basically, it's an eyes-on tool. You can't defuse any IEDs with it. It's basically just to clarify that if you have an IED or not. It's very personal to me. That's why I got in this program in the first place, because of my son-in-law. If my son-in-law would have had one of these when he walked in that house, he'd probably still be alive.
Sergeant Stockwell also said, using the robots keeps soldiers alive.
Keeps you safe.
For years, remote-controlled robots have been used for entertainment. Now, insurgency tool. Reporting for the 82nd Airborne Division's 4th Brigade Combat Team at Fort Polk, Louisiana.
The Recon Scout XT is a throwable mobile reconnaissance device that arms warfighters with instantaneous video reconnaissance of any indoor or outdoor environment. This situational awareness protects warfighters from hidden threats and enables them to make informed tactical decisions that can increase the success of their mission. The Recon Scout XT has 4 characteristics that make it a valuable tool for today's highly mobile land forces. It's small and lightweight, immediately deployable, extremely durable, and capable of seeing in complete darkness. The XT robot is just 8 inches long and weighs less than 1.3 pounds, making it easy to carry in a small pack along with its handheld operator control unit. The total system weight of the robot and OCU is just 3.2 pounds. The XT can also be deployed in under 5 seconds by simply pulling the activation pin and throwing the robot into an environment. A single joystick on the OCU controls the movement of the robot. The XT can survive repeated throws of up to 120 feet and drops of 30 feet. It can also move quietly across landscapes of rocks, sand, and dirt, and climb easily over door thresholds and clothing. Lastly, the Recon Scout XT has infrared optical systems that automatically turn on when the ambient light is low, allowing the warfighter to see in complete darkness. The Recon Scout XT can be specified in any of 3 transmitting frequencies, allowing warfighters to operate up to 3 robots in the same environment at the same time. In the following training mission, soldiers use the Recon Scout XT to search a structure for enemy combatants.
Window, low right.
Off gun. On. Good video.
Coming around to the right.
Deployed. One Tango. Small arms is all I've seen so far. He's retreating deeper in. We got 1 Tango. Small arms, hunkered down under the stairwell. He's center of the building, level Delta.
Got a door.
Possible Tango on the rooftop.
Tango on the rooftop.
Send the robot up.
Power, robot, going up. On the roof, Roger, Tango identified. Alright, I got a Tango in the doorway, small arms. He's retreating back into the room, too dark. IR's kicked on, nothing left, nothing right, one Tango only.
Go ahead, hold on the right, go ahead, hold on the right. Open window, we got a hatch going to the roof.
Hatch on the roof, hatch on the roof.
Let's get the robot up here.
Robot's coming. Off gun.
Get the window.
Got power. We're up. Robot's going up. Ready?
Going up.
Conducting 360. Alright, I got a Tango north edge in the open. East side, I got a closed off room. Looks clear from outside. Tango's getting up. Oh, Tango sees me. He's running. He just ran in the room. Going inside. Tango is in to the right. There's a little doghouse. He's crouched in the doghouse.
Predator A, General Atomics' best-known unmanned aerial vehicle, or UAV, first flew in 1994. That piston-engined aircraft was later joined by a turboprop-powered Predator B, also known as the Reaper. Now the California manufacturer is well into flight testing the Predator C, or Avenger, a turbofan-powered version. The jet aircraft is designed to perform high-speed, long-endurance, intelligence, surveillance, and precision strike missions over land or sea. It features a variety of internal weapons loads, including the 2,000-pound Joint Direct Attack munition, an electro-optical infrared sensor, and an all-weather synthetic aperture radar and ground moving target indicator. Its avionics are based upon those of its battle-tested predecessors, and its ground control station is the same as those for the Predator and Reaper. Avenger is capable of flying faster than 400 knots and can operate up to 50,000 feet for 20 hours. 2 more Avengers are to join in the testing. The second was expected to fly in 2010, with the third to follow. Compared with the first Avenger, which has been flying since April 2009, the second example has a 6-foot longer fuselage at 44 feet and twice the payload capacity at 6,000 pounds. Avenger is being proposed for Britain's scavenger requirement for a deep and persistent surveillance UAV.
I am Greg Parker, and I work in the Microaviary Indoor Flight Test Lab. The Indoor Flight Lab is designed to test micro-air vehicles. We have a Vicon motion capture system which allows us to track a vehicle's position and orientation within about 1/10 of an inch. Knowing the position and orientation of the vehicle this accurately allows us to do all types of testing, from systems ID testing, performance testing, really just decouple all the different technologies that have to go into the development of a micro-air vehicle. Where most of the people in the directorate are interested in working is in the flapping wing flight. And we're looking at developing hummingbirds and dragonflies, very, very small flapping wing vehicles. Right now we're looking at all those different technologies, from birds to small insects and even bat flight.
What makes me proud to work in this facility is knowing that, years down the line, I will be able to have contributed to a new capability for the warfighter. And that's what really excites me about working in this lab, is we're at the very beginning of a new capability for the United States Air Force.
This moth isn't just swinging around, it's been bugged. Researchers at Cornell University can take control of its flight using electrodes implanted into its muscles. Here, signals are sent to its left flight muscle to make it lift that wing. Different signals can be sent for it to lower its wing, to lift both wings at once, or to make them flap. Increasing the frequency of the pulse makes the wings beat faster. If a signal is sent only to one side while the moth is flying, it will veer in that direction. Another group at the University of Michigan implanted electrodes into the brains of June beetles, close to neurons that control flight. A computer program in the device controls the beetle, and here it beats its wings and takes off when a negative voltage is sent to its brain. At the University of Arizona, researchers are putting moths in control and using them as a pair of eyes. They've found out how to intercept signals from their visual system and how to use them to make a robot move. Here, a graduate student demonstrates how the robot can be steered. Combining living and machine components could eventually make robotic systems more effective.
The U.S. military has lost contact with the fastest aircraft ever built during a test flight. The Falcon glider is designed to go so fast that it can get from London to Sydney in under an hour. But the U.S. Defense Advanced Research Projects Agency lost communication with it just 36 minutes into Thursday's flight. The Falcon was launched from Florida into space inside a rocket-propelled vehicle. On reaching suborbital space, the Falcon popped out of the rocket and began its flight back into the upper reaches of the Earth's atmosphere. The glider was expected to reach Mach 20, that's about 21,000 kilometers per hour, during its glide phase. It was to perform a series of test maneuvers in order to assess its performance before making a controlled descent and ditching into the Pacific Ocean. Earlier, I spoke to Philip Ewing. He's a reporter for military.com and an editor of DoD Buzz, a U.S. Defense Online journal. I asked him for more details on what happened to the aircraft.
DARPA announced today that it had conducted this test as planned. The vehicle had gotten away from the rocket ship that you mentioned a moment ago, and then we don't know what happened. We presume the vehicle splashed down in the Pacific, or crashed in the Pacific more likely, as it was programmed to do if it lost contact with controllers. But beyond that, we don't have many details at this point.
Now, if we look at this project, what's the purpose behind it? Why is the Air Force or the Pentagon so keen to put something into low orbit up there?
Well, the context here is that the Pentagon for the past decade or so has wanted something it calls prompt global strike. It wants the ability to strike a target anywhere in the world in about an hour's notice. So it needs a new, very fast, advanced weapon, probably one that involves space or high speeds and high altitudes like this, to be able to get there. And the process going forward is, how do you build a weapon, or how do you build a plane or a spacecraft that can do this mission? And that's where we are with this experiment today.
So how big a setback is this? Because this is not the first time one of these aircraft or one of these gliders have crashed. This is the second time, isn't it?
That's right, and that's an excellent question, and we'll know more going forward as DARPA and the Air Force and the Pentagon talk about this. What they might say is that you have to fail to succeed when you're developing a new weapon, especially something as new and advanced as this. So it's possible they could have learned some good lessons from the test today that they can use if they decide to go forward. But at this point, we don't really know.
So what would they be looking at? What's the next step for them?
Well, what they need to be able to do going forward is test with a real vehicle how something traveling this fast at this altitude actually behaves. You can model it with computers and with wind tunnels to a certain degree, but what the Air Force really wants and what DARPA really wants is to put something actually up that high and have it fly this fast at Mach 20 and just see how it behaves. How can it turn? How can it maneuver? And that'll inform programs like this and others in the future.
I want you now to imagine a wearable robot that gives you superhuman abilities, or another one that takes wheelchair users up, standing, and walking again. We at Berkeley Bionics call these robots exoskeletons. These are nothing else than something that you put on in the morning, and it will give you extra strength. It will further enhance your speed, and it will help you, for instance, to manage your balance. It is actually the true integration of the man and the machine. But not only that, it will integrate and network you to the universe and other devices out there. This is just not some blue sky thinking. To show you now what we are working on, by starting out talking about the American soldier, that on average does carry about 100 pounds on their backs, and they are being asked to carry more equipment. Obviously, this is resulting in some major complications, back injuries, 30% of them, chronic back injuries. So we thought we would look at this challenge and create an exoskeleton that would help deal with this issue. So let me now introduce to you Hulk, or the Human Universal Load Carrier.
With the Hulk exoskeleton, I can carry 200 pounds over varied terrain for many hours. Its flexible design allows for deep squats, crawls, and high agility movements. It senses what I want to do, where I want to go, and then augments my strength and endurance.
We are ready with our industry partner to introduce this device, this new exoskeleton this year. So it is for real.
Now, create full-color 3D models more quickly, easily, and affordably than ever, right in your office. Introducing the Z-Printer 450. The Z-Printer 450 brings CAD files to life as realistic physical 3D models with precise detail and brilliant color, and does so 5 to 10 times faster than other systems at less than half the cost. Dramatically present the proposed look, feel, and style of product designs and prototypes. Vividly display architectural visions, and better communicate 3D information in education, healthcare, and the arts, all in ways that electronic displays cannot. The first automated 3D printer, the Z-Printer 450 is remarkably easy to use and very office-friendly with clean, quiet operation. And it's from Z Corporation, the industry leader in color 3D printing technology. The Z-Printer 450 is for those seeking high-quality color 3D models, plus the convenience of an in-house printer to build those models anytime, anywhere. The uniquely automated Z-Printer 450 simplifies the entire 3D printing process. Self-contained and self-monitoring, it manages nearly every aspect of printing, cutting user interaction time by 40%. Simply import your 3D data file into our Z-Print software, position as desired, and follow the prompts. The system automatically checks supplies and printer readiness, ensuring you always have the right amount of materials to complete the job. If supplies need replenishment, it's as easy as inserting a 1-liter binder cartridge, connecting a powder canister for automatic loading, or snapping in a new printhead. When ready, click 3D Print and watch your 3D model emerge from the bottom up, one cross-section at a time, in 450 dpi resolution. Advanced inkjet technology builds models 5 to 10 times faster than other rapid prototyping systems, so you get your model in hours, not days. When printing is complete, a vacuum and motion system automatically removes up to 80% of loose powder and recycles it for future use. Removing the remaining powder is just as easy, using lightly compressed air in an enclosed chamber that vacuums away particles as you go. Plus, with no physical support structures attached to the model, like other printers, you can say goodbye to dangerous scraping tools and chemical baths. Every 3D model emerges clean and ready for finishing with one of 3 processes that vary surface finish to match any application. Choose a quick dip in Z-Bond sealant followed by a short drying period. Get the same effect by dripping Z-Bond over the model. Or lightly brush with Z-Max Infiltrant for a strong, brilliant color finish. Regardless of which you choose, you get a smooth, vivid color model that lasts. And you get it fast. In fact, from start to finish, this model was printed, depowdered, and finished in under 4 hours. Best of all, the Z Printer 450 is incredibly office-friendly. With a small footprint, negative pressure dust control, noise suppression, and zero liquid waste, it's just like any other printer in your office. Everyone can afford to create 3D concept models, functional product prototypes, architectural models, and more, and do it all in-house. It's fast, it's color, it's easy to use, and it's available at a breakthrough low price. It's the Z Printer 450 from Z Corporation. Full color 3D printing whenever you need it.
A British scientist says the use of drone technology by the military is advancing so fast it could pose ethical problems. Biochemist Professor Rod Flower says we're only a step away from drones, planes or other high-tech weapons being controlled by thought alone. Simon Newton's been talking to Professor Flower.
It's long been the stuff of computer games, but not, say scientists, for much longer. Advances in neuroscience developed to treat mental illness could also have an untapped military use, allowing weapons to be literally controlled by brainwaves.
Well, first of all, you have to have something on your head or something to gather the information about what it is you're thinking about, and you need to train the computer to be able to recognize patterns in your neuronal activity when you're thinking about something. So let's say go left or go right. Once the computer can understand that, then you can feed that information into a weapons system or a wheelchair or anything else, or cursor on a computer screen and so on.
The US military has already experimented with neuroscience. In simulated tests, it found that troops' ability to spot roadside bombs and snipers doubled when a weak electrical current was passed through their brain. But the Royal Society report says it could go much further. Pilots could operate unmanned drones directly from their thoughts, while troops could control weapons simply by thinking. Recruits could also undergo brain scans to find fast learners and risk takers.
The report also looks at how drugs developed for conditions like dementia could be adapted for military use, allowing soldiers to go longer without sleep, to be more alert to threats, and to cope better with battlefield stress.
Other drugs could be used to make captives more talkative or subdue an enemy. But scientists say there will be ethical concerns about turning medical research to military use.
Ours really deals with the impact that these new technologies are making or might be expected to make upon the military and also law enforcement.
The MOD's Future Integrated Soldier Technology Programme, or FIST, is already looking at ways of fitting British infantry with helmet-mounted displays linked to a new battlefield communication system. Although brainwave weapons may still sound like science fiction, the Royal Society says they're already on the horizon, the next leap in military technology, harnessing the human brain. Simon Newton, Forces News.
This demonstration of data mining will be based upon a study I completed in the 1960s. Bell Canada was kind enough to donate the data that they had collected on long-distance calls from London, Ontario, to places in Canada and the United States during 10 days in April of 1964. I randomly sampled the data and produced a scatter plot. The one you see on the screen is not the original, but rather a smaller simplified version. The model used to generate an expected number of calls at each destination is called a gravity model, where P sub I is the population of London and P sub j is the population of the place called. The product, P sub I, P sub j, is divided by the great circle, that is, straight line distance, between London and the place called, D sub ij. The basic assumption is that for a randomly selected caller in London, the larger the population of a place, and the shorter its distance from London, then the greater the likelihood that the person called will be in that place. We know that there are variables other than population and distance which will influence calls, and it is hoped that the scatter plot will help in their identification. The scatter plot initially shows no significant correlation, as you can see, between the actual and expected calls. Let us now sort the points on the basis of their language and national identity into those located in Quebec, the rest of Canada, and the United States. The points on the scatter plot are now colored red for Canada, excluding Quebec, white for Quebec, and blue for the United States. Within each of the three groups, a clear relationship between actual and expected calls emerges, to which we may fit a so-called regression line, or line of best fit. We now turn our attention to the outliers, those points within each group which either lie at some distance above or below their regression line, or lie among points of a different language or national identity. An example of the latter, points outside their groups, are here circled in red. The white points in the study were largely Anglophone communities of Roxborough and Pointe Claire in Quebec, while the blue points were the favorite winter retreats of Canadian snowbirds of Palm Springs, California, and Clearwater, Florida. Remember, this is back in the 60s. Circled in blue, on the other hand, is a point within its own group, its own Canadian group, whose calls were much larger than expected, that is, above the regression line. One such place in the study was Oromocto, New Brunswick. Oromocto, as you all, I'm sure, know, is the home to many soldiers of 2RCR based in nearby CFB Gagetown. In 1964, London was still the home state, or station rather, of 1RCR. It is likely that this military-family relationship contributed to the observed higher incidence of telephone calls between London and Oromocto. Now, whether or not this approach to data mining can really help in filtering out terrorist activity is controversial indeed, due to the relatively small numbers of such radicalized individuals, even relative to their own ethnic or religious community. Well, perhaps not today, but who knows about tomorrow?